we're going to do a couple of these. What fraction of the first 100 triangular numbers are evenly divisible by 7? So you said, what's a triangular number? Which is a genius question. Because if you don't know, then it's kind of hard to answer. So I'll show you. That's the first one. That's the second one. So 1, 3, and then
6.
That's the next one. And then
9. No.
This is the next
10.
one. 10.
15.
Sure. So what it is the nth triangular number is 1 plus 2 plus ... up to n.
Okay.
All right, so the fifth triangular number is 1 plus 2 plus 3 plus 4 plus 5.
Okay.
Okay? And they're asking us what fraction... Now, do you know the formula to add this up?
No.
Okay, I'll just give it to you. It's n plus 1 over 2 times n.
N plus 1 times...
n plus 1 over 2 times n.
Okay.
Right? Well, not right. I mean, you don't know. So how do I do that? Basically, I want to say, think about this. What if I am adding 1 plus 2 plus 3 plus all the way up to 48, 49, 50, 51. Okay? So let me just erase this. This is an example that will show you how to do this. What is the average of the numbers in this list?
50? No.
So one way to do it...
25.
No, 26, because I went out to 51.
Oh, yeah.
If I average 1 and 51, that tells me the average.
It's 52 divided by 2.
Right. In other words, if this is n, and this is 1, it's n plus 1 over 2.
Okay.
That's the average. Okay, how many numbers are in the list? N numbers, because I go from 1 to n.
Okay.
All right, so this is the average times the number of numbers. Okay, that's always equal to the sum. Think about how I find the average. I take the sum and I divide it by the number of numbers.
Okay.
Right, and that's exactly the same equation. Does that make sense?
Yes.
All right. So in other words, I can think about this also as like 1 plus 2 plus all the way out to 26. And here I've got 51 plus 50 plus all the way out to 26. They all add up to 52.
Okay.
Right? And so 26 times 52, which works out the same way. Okay. This is the formula for the nth triangular number.
Okay.
All right?
Yeah.
All right. So this is also, by the way, n plus 1, choose 2. Okay? Did you recognize that?
No, not it.
This is also n plus 1, choose 2. Okay. So now, how can a number like n plus 1 over 2 times n, how can this be divisible by 7? 7 is prime, right?
Yeah.
So that means, it's not like, so that means either n plus 1 or n has to itself be divisible by 7.
Okay.
You see what I'm saying?
I think so.
So like in other words, if n equals 6,
Okay.
then I have 7 times 6 over 2, which is 21. We're good.
Okay.
In this case, n plus 1 is divisible by 7.
Okay.
So n plus 1 divisible by 7. Right? Next, what if n equals 7?
What?
Right? Then 8 times 7 over 2, which is 28. Check it off.
But that is divisible by 7.
N is divisible by 7.
So
Okay, now when n is 8, it doesn't work. The next time it's going to work is going to be for 13 and 14.
is there like some kind of pattern here or something?
Sure, every 7 numbers, we get 2 numbers in a row where n plus 1 is divisible by 7, and then n is divisible
So
by 7.
5 don't work, then 2 work, then 5 don't work, then 2 work.
Exactly. So basically, if you look at all the way up to 98, all right? So we've got 98 is 14 times 7. Okay? So 5 don't, 2 do. So 2 sevens. So
the answer
28 out of 98 are going to work, and then the last 2 aren't going to work, so it's going to be 28 out of 100.
Okay. So we have to simplify that.
Right. Can you do that?
28 divided by 2 and 2, or divided by 4 and 4. So that would be 7 over 25.
Is that right?
I have no idea.
Hope so.
Yeah.
Okay, great. All right, let's do...
Wait 1 second. Can you explain the last part?
Yeah, sure. So the idea was we have this formula for triangular numbers.
Okay.
Okay. We want to know, where can 7 come from? Like, 7 is prime, and so we need 7 is a factor of either n or n plus 1.
Okay.
Okay, so if I go through my list of all the n's in the world, 1, 2, 3, 4, 5.
6,
Okay,
7.
here 7 is a factor of n plus 1, and here 7 is a factor of n.
Okay.
8, 9, 10, 11, 12, 13, 7 is a factor of n plus 1, 14, 7 is a factor of n.
Okay.
Okay? So here we would have 13 times 14 over 2. Here we would have 14 times 15 over 2. Right?
Okay, yeah.
Divisible by 7. Both of these are... So here we're going to have 6 times 7 over 2. And here we're going to have 7 times 8. 7 times 8 over 2.
Oh, yeah.
Right? The important thing is each one of these, every time I have a 7 in the numerator, it is a factor because it's prime. It's not like the 2 divides out the 7.
Okay.
Right? Now, this problem would be much harder if they asked for 12.
Oh, yeah.
Because there are lots of ways to make 12. You see what I mean? So, okay, so basically, this pattern continues all the way up to 98.
Okay.
Okay? So, we say like x over 98 equals 2 over 7.
Okay.
Okay, turns out x is 14. I'm sorry, x is 28.
Is equals to 2 over 6.
So in other words, 28 numbers work, 28 out of 100.
X is equal to 28. So 28 over 100 is equal to 5 over 7? What was it? What was it? Is equal to...
Oh, 7 over...
Oh, okay.
Yeah. Well, you can reduce it, right?
7
now, it's important. You also could look at the actual triangular numbers, right? They're 1, 3. Now, how am I doing this? I mean, okay, now add 4, 10. Okay, now add 5. Now add 6. Now add 7.
Okay.
Okay, these are divisible. Okay, now add 8. Add 9. Add 10. Add 11. Add 12. No. Add 13. 91. This is going to work. And then add 14. 105. This is going to work. Okay. So if you weren't so sophisticated as using the formula, you could actually notice the pattern. by going through the actual triangular numbers.
Okay.
Okay? All right. Next problem.